Okay, YouTube, in this video we're going to take the exploration of lines a little bit further and look at parallel and perpendicular lines. And so previously we've looked at slope-intercept form of a line, and I explored slope pretty extensively and seen that the slope of that line actually affects the steepness of a line. And so let's go ahead and make a couple of hypotheses here, but starting with this, parallel lines, what could we say about their slopes? Well, if I were to have, say, the graph of a couple of equations here, that happen to be parallel to one another. And so we could say that this is maybe line 1, and oh, no, not that one. And this would maybe be like a line number 2. We could see that the slope of the first line would have to be the same as the slope of the second line for these to be parallel. Now, this works with any slope, no matter what. As a matter of fact, we say y equals 2 times x. Maybe we'll do a line that has a y-intercept of 0 and has a slope of 2. And then with this, we say y equals 2x minus 3 or something like that. You could see that both of these lines have a slope of 2 and therefore are parallel lines. Now, my next question would be, well, what would have to be true about the slope of, say, a third line in order for these to be perpendicular? And so by perpendicular, of course, we mean meeting at a right angle. And so one thing we have to basically accept is that if one line is increasing or going uphill or rising from left to right, and we want for there to be a perpendicular line, then as long as these aren't vertical and horizontal lines, we're going to have a negative slope if one of them is positive. So maybe perhaps we try something here. Maybe we'll do a negative 2x and see if these are perpendicular. Now, in terms of what I see here, it certainly looks clearly non-perpendicular to me. But the trick is this. You have to change the relationship to rise over run. And so that is to say that this 2 here is really 2 over 1 times x. Let's see if I can get this to work here. 2 over 1 divided by x. And so what you're looking at is something that rises 2 and runs 1. If we want to have perpendicularity, then what we need is something that doesn't just fall 2, but falls at a reciprocal rate is what we have here. So that is to say the reciprocal of 2 over 1 is 1 over 2. We could say, what if we did a negative 1 over 2x? And so what you're going to see now is something that is clearly perpendicular, because as every time this goes up 2 over 1, say the green line or the purple line, this one goes down 1 over 2, and so that's going to cast perpendicular lines. So with respect to parallel lines, they have to have the same slopes. With two non-vertical lines that are perpendicular, okay, let's go ahead and sketch these in here. Perpendicular, we're going to see that this is maybe line 1. And then line 2 has to meet it at a right angle. So we're going to be clear on this one here. We say line number 2. We would say that the slope of the first line is what we say is the negative reciprocal of the second line right here. So as an example of negative reciprocals, okay, we could say that maybe a couple of examples here. If slope is equal to 2, then that's the negative reciprocal would be negative 1 over 2. Or we could say, just as another example here, what if I had something like negative 3/7 is my slope. M is negative 3 over 7. That's slope 1. Well, then slope 2 being perpendicular would be a positive 7 over 3. So what we're going to be doing in this video is kind of playing with this idea of parallel and perpendicular, and also writing the equations of lines that satisfy given desired characteristics. So let's go ahead and take a look. We say find the slope-intercept form. So we want the y equals mx plus b, the slope-intercept form of the equations of the lines that pass through the point 2, negative 1, and are in one case parallel to, and in the other case perpendicular to the line 2x minus 3 equals 5. So let's go ahead and, first of all acknowledge one thing. If we want to write the equation, we need to use point-slope form to write the equation of a line. So point-slope form, remember, is this y minus y1 equals m times x minus x1. So what this requires of us is that we have an x1 and a y1, but it also requires that we have a slope. And so what we're told here is a point x1, y1. As a matter of fact, we're going to go ahead and make a note here. x1, y1 is equal to 2, negative 1. We have both of those values right there. But we're told that we want this line to go through 2, negative 1, but be, say, parallel to this line over here. So what do we know about two lines that are parallel? Well, I know they have the same slopes. And so this is going to require us to find the slope of this line right here. So one way to do this is, well, easily we could just get y by itself and put this in slope-intercept form. So to get y by itself, I'm going to subtract the 2x, put it on the other side here, and we get left with negative 3y on the left is 5 minus 2x. And then I'm going to go ahead and divide everything by a negative 3 here. So on the left, now we get a positive y. And what it looks like we get over here is this. Because we have a one-term divisor, or we call this a monomial divisor. Okay, we can take every term in the sum or a difference in the numerator and divide it by that 3. So we get a positive 5 over a negative 3. I'm going to write this as a negative 5/3, and I get a negative 2 over a negative 3, which actually comes out to be positive. I'm going to say 2/3, and I'm going to say that this is x. So the neat thing about this here is that this line, the one that we're comparing it to, has a slope of 2/3. Okay? So in this case, since I want it to be parallel, we're going to go ahead and keep this as a slope of 2/3. And we'll just go ahead and put this into our point slope form. So y minus y1, where our y1 is negative 1, equals m. Our m here is 2/3 if we want it to be parallel. And then x minus x1 here, our x1 looks like is a 2. So subtracting these out, simplifying both sides, since we want y equals mx plus b form, we get y plus 1 on the left. Here we get 2/3 times x minus, well, this is 2 over 1 times 2 over 3. Multiplying straight across, we get 4/3. If I were to now subtract 1 from both sides, we will need a common denominator, but that's not a big problem here. We get minus 4/3 minus 1, which 1, if we were to say is 1 over 1, our common denominator would be 3, so we really get minus 3/3, and then combining like terms here, we get y equals 2/3 x minus 1/3. So one thing that I want to do here is this. Let's go ahead and take a look at these graphs here. Our initial graph here is 2x minus 3y equals 5. So to pop over here, we'll type this in, 2x minus 3y equals 5. You can see that it is this line right here. What we wanted was a line that went through the point 2 comma negative 1. So let's go ahead and put this point up here as well. We say 2 comma negative 1. Apologies. And so we want a line that goes through this point 2 comma negative 1, but it is parallel to this line. Well, what we did was we were able to come up with this equation here, which was y equals 2/3 x minus 1/3. And so what I want to do is go ahead and type that in. We say y equals 2/3. Let's see if I can get this here. There we go. 2/3 x, and this was minus 1/3. Cool thing is 2/3 x minus 1/3. Let me check my signs here. Oh my goodness, you guys, two negatives. When you take negative 4/3 and negative 3/3, it's negative 7/3. So that's going to help things a little bit here. Negative 7/3. Apologies. But taking a look at this negative 7/3, we'll just go ahead and switch this over to 7. You can see that it definitely goes through 2, negative 1 and is parallel. Now in this case, the next case, what we want to do is come up with a line that goes through 2, negative 1, but that is perpendicular to this line right here. So in terms of the perpendicular example, let's go ahead and write this down here. We say perpendicular going through 2, negative 1. We would say that our point is 2, negative 1, so we have x1 and we have y1. What we need is a slope, and because we want it perpendicular to this line, remember perpendicular slopes are opposite reciprocals. So we have a slope is negative 3/2. A point x1, y1 is 2, negative 1. So we'll go ahead and put this into our point slope formula now for all of our desired quantities. So we have y minus y1 equals m times x minus x1. Let's go ahead and substitute our values here. In this case, we still have for our x1, y1, 2, negative 1. So we'll put in a negative 1 for our y1, a positive 2 for our x1, and then for our slope, we're going to use this perpendicular slope, negative 3 over 2, the opposite reciprocal of the positive 2/3. So looks like when we simplify it this time, we get a y plus 1 again on the left here. Distributing on the right, we get a negative 3/2 x, and we get a negative times a negative is a positive times a positive here. And then this 2 will cross cancel with this 2 here, so we end up with just a 3. And so just to take a look at this here, I suppose I'll subtract the 1 over here to isolate y. y equals negative 3/2 x plus 2. What we're going to do is go take a look at this graph, negative 3/2 x plus 2. And so we have negative 3x, let's see, plus 2. And that also goes through 2, negative 1, and you can clearly see that this is perpendicular. So parallel and perpendicular lines either have same slopes or negative reciprocals, respectively, and then still using point slope form to write the equation of a line is a pretty essential tool. Cheers.